Hello everyone. So today we are going to solve the daily question from Leetcode. So let's say the question. You can say the question name is bus routes, and this is the hard level question. And the question is you are given an array routes representing bus routes where routes of I is a bus route that the ith bus repeats forever. For example, if route 0 is equal to 157, this means that the zeroth bus travels in the sequence like 157, then again 157, then it will repeat forever. Okay. You will start at the bus stop source. You are not on any bus initially, and you want to go to the bus stop target. Okay, and you can traverse between bus stops by buses only. Okay, so suppose uh, let's see the example. After that, let's read the question first. Return the list number of buses you must take to travel from source to target. Return -1 if you cannot go to the target value. Okay, that means how can we think this problem? So, as let's see the example one for better clarification that we have given a routes as an input where you can see that we have an 2D array. Okay, so in this case, this is one bus and this is another bus. So we have total two buses. And suppose this is the zeroth bus and this is the one bus. Zeroth bus will go to the stop one, then two, then three. Then you can traverse any, you can go any of this by using the zeroth bus. And for the one bus, you can go in three stops, then six stops, then seven stops, any of these. Okay. As per the question, you can say the source is one. So from the first stop, we need to go to the sixth stop, which is our target. So how can you go there? You can say that the source is one. So for getting the source, we need to write in the first bus, which is zeroth bus, and let's have an ID. This is zeroth ID, and this is one ID. So zeroth bus will start from one. Then it will maybe go to we need to go to six, right? Okay. Then we don't care it's go to so two or not. Then we need 7 because after that you can see 7 is common there. When you come to 7, then you can change your bus, and from the bus you can ride in the bus number 1. This is bus number 2, bus number 0, and this is bus number 1. And in the bus number 1 it will go to the 3 stop. Okay, 3 stop. Then after that you can go to the 6 stop, which is our target. And how many bus is you have needed, the minimum buses you have needed to travel from source to target? Yeah, you need two buses. So in the example two, you cannot go to the cannot reach the target. So that's why the output is -1. Okay, so let's solve this. So how can we solve this? So let's have a bus IDs, right? Okay, so we'll use an unordered map to make this thing vector where uh, we'll just add some bus stops, right? Let's write stop to stop to IDs. Okay, stop to ID. Then what can we do? That we can use the for loop to add all the pairs, all the everything to get the stop to ID properly. So let's have this thing like I equal to 0. It will go up to I greater than the size of route to add everything, and then it will increase every time. And after that, let's have an ID of the bus. Maybe the bus ID will be the let's suppose it will be I, because we have taken that this is the zeroth bus, this is one bus, and let's suppose this is the ID. And then we have some vector integers like stops, which I have told earlier that in the stops you can have the routes of I as the vector. Okay, because this is a 2D vector, so we just taking the 1D vector to add in the stops, and after that we can traverse the bus stops. Okay, so let's suppose this is the stop, and let's traverse the bus stops, and let's add this thing to our unordered map. Okay, maybe this dot, this dot, you know what? This is the stop. It will stop to ID to stop, and it will push back. You know what? The ID will be pushed back here. That you can go from here to here. For everything will be in a queue because suppose you need to, in this case, you need to go to this thing. Then after that, you can have this thing, and we'll implement one kind of BFS to solve this problem. You can will see that. So for solving this using BFS, we can use queue is needed, and let's have a pair. In this pair, we'll add like a current stop and the bus traveled. How many buses traveled till now? That thing. Okay. So let's have the name is queue is queue. Then let's have an unordered map again. Unordered map again. And what can we do? We'll check that nothing is visited again. Okay, if a bus is visited once, then it will not take the bus again because it will make our calculation very bigger. And also, well, if we have gone to the one, then we'll not check for one again. Then if we go to the two stop, then we'll not check if two, because if two has not any answer, we'll not check it again. We'll just have bus visited, and another one is bus stop visited. Okay, let's have two things because we have two cases. And after that, let's push the first the source thing. The For these things we have a source. We can have make pair, we can use make pair, or also we can use like this, source and zero. And suppose the bus stop visited, that the bus stop we have visited is, the source we have already visited by adding in the queue. And this is the true. Okay, you can add one, everything is okay. And we'll check up to when the queue is not empty. Okay, so let's have queue is not empty. So what we'll get, uh, wait for a second, that int size is equal to, queue dot size. Then up to we will have another while loop. Will check every cases in the queue. We'll have another pair. Suppose we have int, then int maybe there, and let's have the pair name as p, which is equal to dot font. Okay, we need to also pop this queue, right? Yeah, queue dot font, and let's pop the queue from here. Let's have the current stop, which will be current stop is p dot first, and another bus travel bus travel, which p dot second. Okay, if the current stop is is the target stop, and that means we got our answer. We'll just return the value of the how many bus it is travel. Okay, that means bus traveled. Okay, okay. If not, we'll check the neighbor nodes, right? And for auto, bus stops, then these things is visited or not. That means the bus visited. What is the name of the bus visited here? Okay, bus vis. Okay, bus visited of the bus. If not visited, bus is visited. Let's make the bus is equal to true. It's okay. We'll just do one thing. We'll just check another bus stops, right? Which will be bus stop and routes of bus. Okay. If again we need to check if the bus stop is already visited, then we will not check it again. Okay, right? That means the bus stop visited of the bus stop will not check it again, right? Like this. is if mm, we need to do that bus stop visited of bus stop is equal to true. That means we have visitor right now, and let's push it back to the queue. Okay, okay, and every time bus travel will be increased by one because first time the bus is traveled one bus, then after that it will go to the another another bus, then the bus travel will be increased by one. Okay, and initially the bus travel is zero, and if we have not got any value from here, that means we cannot reach the the main our target. Okay, we cannot reach our target. That's why we'll return -1 at the time. And let's check is our code is running perfectly or not. Let's run this code and let's check a minute. Bus stop. Okay, we have not used bus stop over here. So I think this will be bus stop visited. Okay, let's check right now. Let's run it and hold for a second. Uh, let's check it. Okay, as you can see that the code is accepted. So what will be the time complexity of this code? Like you can see in this code, we just traversing all the buses to check it has any way to find the to get into the target value or not. Okay, so for this case, suppose we have n buses and every buses we have almost m stops. Then will you need to traverse almost n into m. N into m elements. That means the time complexity of this case will be O of n cross m. Okay. Okay. So what will be the space complexity? So as we know that we just have to use some hash maps, some ordered maps, which take up to all bus stops. And how many bus stops are there? N cross m, which we have got in our time complexity. So the space complexity for this case will be almost same, like it will be O of n cross m. Okay, I hope you guys have understand the code part, and thank you guys for watching. I'll see you in the next time.